Yeah. So my presentation is all about observables and applying them to formulas for later analysis, I suppose. So calculating the expectation value of any observable, you can normally follow this equation. You plug in the operator into this integral of the wave function over space. So in the code, there were 3 examples of this: momentum, position, and energy. And you can see for momentum, we plug in the momentum operator, position, the position operator, energy, the energy operator. And over here is the examples in all the codes. So method 1, 2, 3. But you can see it's just the wave. It's just plugging in that operator into the wave function equation, and it's also normalized. Here is a plot of those expectation values for position and for momentum. P now was set to 0.75, so you can see when it crossed over the boundaries of the cell for position right there. And momentum there's slight errors, but it's close to 0.75, and it's just going to stay constant the whole time. The uncertainty of position and momentum. We learned in class that as time increases, the uncertainty of position is going to follow a quadratic graph, and as you can see when you plot this this standard deviation of the position, which is calculated by variances, and it's put into an array as the code goes forwards and through the loop. And for momentum, we learned that it is held constant. So these are really small values, so it's essentially staying at 0 the whole time. And it's similar, just standard deviation, it's accumulated into an array. And this is just a plot of that array. And maybe I should have talked about this earlier, but accumulating the expectation values into an array, as it's going through this loop, it calculates an expectation value at that specific time, and it puts it into an array at each increment. And as it loops, it does this for every expectation value, whatever you set it to. I think it was 200. And at the end, you can use that array you can analyze it. Saving numerical data into files is just kind of an extra thing that I had to talk about. You just type this, you type the variable you want saved. Right? No, this is the name of the file, and then the variable that you'd like to save, or the array.
Yeah. Okay. Please join in thanking Nick. Any questions you wanted to ask about programming this expectation value convolutions? Which observables do you like it most?
Momentum's really easy, I feel like. I couldn't find in the program like an accumulation of the energy expectation. Yeah.
So you would like to add it?
Yeah.
As a little programming exercise.
That could be something. Yeah. I don't think it'd be that hard even.
Okay. Yeah. But it would be valuable. Yeah.
Yes.
Thank you. More questions? If no, let's thank Nate once again.